All right, so we know a lot about geometric series. We know that they converge when absolute value of r is less than 1, and we know that they converge to a sub 1 over 1 minus r. Are there any other classes of series that we can know whether they converge or not just by the form of the series? So here's one. So in fact, we just did one, 1 over n squared. So that was this sum with the value of p equals 2. That's what 1 over n squared was. So that's called a p series. In fact, so this sum that we just did, this one, all right, the fact that this sum converges, all right, that sum is a p series with p equals 2. All right, it's 1 over n to the p, so 1 over n squared. What about 1 over n cubed? Does that converge? What about 1 over n to the 1/2 power? 1 over square root of n. Does that converge? I don't know. Let's find out. Well, I do know, I'm lying, actually. All right, we're going to investigate for what values of p this sum converges. What values of p make it converge? All right, so first of all, we're going to eliminate some easy cases. So for p is less than 0. So think about negative values of p. So for example, 1 over n to the negative 2, right? Well, what would that be? That would just be n squared, right? So my sequence of values, I'd be doing 1 plus 4 plus 9 plus 16 plus etc. So my terms are going to be increasing. So there's no way that is going to converge if n is any negative number, right? It could even be 1 over n to the negative 1/2, right? So then that would equal the square root of n. Do the algebra there, it's square root of n. So that would go 1, square root 2, square root 3. It's increasing more slowly, but these values are still increasing. I could have written 2 there, but I didn't. The values are still increasing. So we have a mathematical way to say that since the numbers are increasing, they're not getting smaller, the sum cannot converge. All right, so what we can say about it is the limit as n approaches infinity of the terms a sub n is equal to infinity. In particular, it's not equal to 0. So remember that one thing that we had before was if the limit as n approaches infinity of the terms is not equal to 0, then the sum of a sub n diverges. All right, that was called the nth term test. All right, so we can say that for p less than 0, the p series diverges by nth term test. Now that also happens if p equals 0. All right, for p equals 0, the limit as n approaches infinity of a sub n. So if I have p equals 0, I'm going to have everything to the 0 power is 1. This is 1 over 1, 1 over 1, 1 over 1. But if going 1 plus 1 plus 1 plus 1, it's going to diverge. The limit as n approaches infinity is 1. All right. So in either cases, for p less than 0, for p equals 0, all right, the series diverges by nth term tests. So we can now say for p less than or equal to 0, the sum from n equals 0 to infinity of 1 over n to the p, that p series diverges. All right, so that is one conclusion, okay? But wait, there's more. All right, so now let's investigate. We're going to investigate what happens when p is greater than 0, because that's so all we've done now is sort of eliminate the trivial cases. So what about so we can say, here's what we can say: a p series diverges for p less than or equal to 0. What about p greater than 0? Well, we're going to investigate that, and first we're going to look at a certain limit. So first, this, by the way, is called a lemma. I always like that nifty word I learned in college. It means lemma is a preliminary result that we need in order to show something later, but you wouldn't necessarily see it coming. So it's preliminary. It's a lemma. All right. What is the limit as x approaches infinity of x to the n, depending on what n is? All right. So depending on what the n is. So for example, what is I'll put some examples down here. Examples. What is the limit as x approaches infinity of x to the negative 2? All right, so that is equal to the limit as x approaches infinity of 1 over x squared. Numerator is bounded, denominator increases without bound. That limit is 0. All right, what is the limit as x approaches infinity of x to the negative 1/2 power? So that would be limit as x approaches infinity of 1 over square root x. Again, the denominator expands without bound. Numerator is bounded. That limit is 0. All right, what if I have x to the 0 power? Limit as x approaches infinity of x to the 0 power. Well, I'm going to have 1, 1, 1, 1, so that limit is 1. All right, what about limit as x approaches infinity of x to the 1/2 power? So that would be limit as x approaches infinity of square root x. Well, as x approaches infinity, the square root of x is also approaching infinity, so that equals infinity. And what about limit as x approaches infinity of x squared? Well, that's certainly going to be increasing. You can think of the graph going like this. That limit is infinity. All right, so here's our lemma. It looks like the limit is 0 for n less than 0. All right, so this limit is as x approaches infinity of x to the n. So you got to keep track of like what's the variable here. So for a fixed value, certain fixed values of n, what is the limit as the x approaches infinity? All right, that equals 0 for n less than 0. It equals 1 for n equals 0, and it equals infinity for n greater than 0. All right, so this x to the n only converges for negative values. All right, so that's our lemma, and we're going to use that next to investigate these p-series for p greater than 0.